Hello, I'm Chris. This is Gross Models, and welcome to part 3 of my look at the components in the Adventure Kit 2.0, Day 0, 2. Just call it Adventure Kit 2, I think. So, yes, I shall pop down to the bench and we'll have a look at the next few, I don't know how many, 5 or 6, I should think, components in the kit. Okay, the first item in today's video is the real-time clock module. This is just a little board, keeps track of time basically. It does have a battery fitted to it, so it remembers the time even when you unplug it. So this, if I bring up the board and the serial monitor, I have pre-programmed with the correct time and date, as you can see being reported down the bottom of the screen here. It is indeed the 26th of March today, 2023. And I put it for GMT. It's actually showing it's an hour behind because I've decided to go with GMT rather than anything else. So that will basically just keep ticking away and keep activating. If I unplug the board, if I unplug that completely, that is still running. It's still ticking away using the battery. Now the battery will last for a long time in this. There's no display or anything on there. So yeah, it's going to last for several years, I would expect. If I plug that back in there, and we see we've got the little red lights come back on. So that is hopefully still reporting back. As some reason it's gone a bit strange. Okay, that has reset. It came out as a strange glitch and then reset. It might be something to do with these pins not locating quite as well as they should into the board. Although that shouldn't affect the running of the thing. I shall reprogram it. To reprogram it, we put in not on there, on the actual thing, not the screen grab of it. Onto there, we put in a 13-digit string of the time and date. 23 is the year, 03 is the month, 26 is the date. Then a single character for the day of the week it is, 1, because it's a Sunday today. And then I shall put in 11:56, because that is about the time at the moment. So I've sent that now down through to the board. Wrong length, 11 characters. What did I miss? I missed the seconds at the end. Let's try that again. 23, 03, 26, 1, 11, 56, 46. There we go. That now should be the correct time sent. Correct length, passing, it says. Now converting that to that. There we have it. Once again, programmed correctly, apparently, for that on there. I'll unplug this. Apparently that as well. Not that that should make any difference to it at all. But if I leave the board powered up, that might make it work better. So that, say, should be keeping the power, keeping it running. And if I plug that back into there, what have we got? No, it's gone strange again. I don't know. Oh no, there you go. It went strange, but it's come back. There we go. For some reason, I don't know what that 2165 was. That might be the day of the apocalypse. We'll find out in 130 years. But yeah, there we go. That is the real-time module. Next up, we have a fairly simple component. This is a water level sensor. Now, I thought that it was completely different. I thought it was just going to say if there's water or not, but it is more advanced than that. It has a little bit of circuitry on it, but not much, and mainly it's just these metallic traces. So if we wire that up, I've already wired it up, you know I've done it all in the background, so you don't have to worry about it. We get a little flashing light on there, obviously to say the power is in, it is working, at least a little bit. We have, if I bring across the code, we've got some code. What have we got? We've got a serial monitor, obviously being used in there. It's saying water detection pin 0, power pin, obviously that's how I've wired it up. Digital write, power pin low. So it's printing water level, as you can see down here. This is a function. Power pin, water detection. Basically, it returns a value on how deep the water is. Now, I have purposed in a brandy glass. Unfortunately, no brandy in it. It has just got water in it. So what I'm going to do is insert this into the water. You can see it's saying water level 0. If I touch that in just a little bit, you can see it shoots up already to 300. It seems to be that's about as low as it gets. If I put it in further, lead all the way down to there, you can see the number gets bigger. So you can actually tell how far up the water has gone. Lower again, bigger again, by reading the numbers. Now, when water is not on it anymore, I have noticed in my rigorous testing of about a minute ago, it still reports back numbers because it's still got moisture on there, as you can possibly make out. So yeah, it will obviously evaporate at some point and not be a problem. Or you can give it a wipe down. I think I won't wipe down very much. If you have a soft cloth to hand, which I don't, I should have pre-thought about things like that, but there we go. If I just keep trying to wipe it, there we go, it's gone down to 50. Almost no moisture there at all, it's detecting. There we go, back down to 0 because I've wiped off all of the water. So yes, that can be useful if you use it as a plant watering or leak detection, that sort of thing. So there we go, that's something of use in the adventure kit too. Right, the next item is a sound sensor, basically a microphone and other components as well. I believe that this is to tune it and to, yeah, but I've wired it up already. It's basically power and 2 signals coming out. If I plug that into there, you should see 2 lights come on. If I then come across to the code and upload that, I've been trying to make sense of the code as I go along on all of these. This one is very short, so I should be able to figure it out. Basically, we're setting up pin mode 2 is the input, and the serial is at that baud rate, which is fine. It's setting the maximum to 0 and setting up a loop. Digital reading on 2 and analog reading on 0. I'm not sure why it's got 2 readings, but then we're printing the digital reading out and printing the maximum, and then waiting for 1/100th of a second, 100,000th, 100th of a second, I think. If I send that to the board, we then get 3 numbers that come back: the minimum, the current, and the maximum. Now the maximum is 20. That's sort of the background noises. If I make a noise, it seems to be a little bit. Yeah, there we go. If I pick it the right time at the right time, it's gone up to 33 because that's obviously the loudest that it went up to. I can't seem to get a consistent middle number, but if I go closer, you'll see me go closer. Hello, hello, I am talking now. It's gone up to 100. It peaked at 100, and that's the maximum that it will read. So it is doing things. It's just that this particular software is not showing us. It's not showing us the middle number for long enough, but it only needs to grab it for a fraction of a second anyway. So I'm not sure. There's obviously a way of doing it, but I don't know how. But it's working. It's doing things, and again, I can understand how you can just read that to get a peak volume. It's not really suitable for recording messages or things like that. It's just to monitor the level of a sound. So that's that. Let's move on to the next part. Next up today is another little component. This is the temperature and humidity sensor. I thought it was a little breadboard thing, but it isn't. It's a temperature and humidity sensor. I've already done the wiring there. Again, it's only a 3-pin, this one. So there's just power and output, which if I plug that into there and we go to the code, you can see it's very easy. It's just monitoring the serial monitor, the humidity, the temperature, and the heat index. I don't know what a heat index is. I'm assuming it's also just a form of temperature. So we've got a humidity of 61%. I assume that's normal. I've got no idea. Temperature of 22.3 in here at the moment. 72 for people who use that strange unit of measurement. It's comfortable. Could be a little bit warmer, but it's okay. The heat index is a little bit lower than the temperature. I don't know if that's an actual thing based on the actual temperature it's monitoring and it calculates it. I don't know. But there we have that. I've got no way of changing the humidity. The temperature I can increase somewhat. Let me unplug it. I shall put it in my moderately warm hands for just a few moments and see if that kicks it up a little bit. It might. Breathing on it might increase the humidity as well. Let's plug it back in and see if that's made any difference. It kicks in. It says the humidity has indeed gone up to 73 and the temperature has gone up a little bit as well. So I would assume that that will go back down naturally. There you go. It's already gone down to 72, 71. And the temperature is actually going up. That's a bit strange. But there we go. That's another sensor in our arsenal of things that we can find out and sense and use going forward. This is the ultrasonic sensor. It's two sensors in one. Well, it's one sensor and one emitter. Basically, it sends out ultrasonic sound from one, I don't know, and receives it on the other. Actually, it says T and R. So it's transmitting and receiving. It sends out ultrasonic pulses from this and picks them up on this, and a clever little bit of circuitry on there and in everything else. It detects how far away something is from the unit itself. The coding is quite simple and there on screen. I did have to correct it from the published site on the Inventor site. They missed out two semicolons just up there, which obviously easily done. I didn't notice that it was missing, but I know nothing about this. The Facebook group helped out almost immediately as soon as I posted the question. Apart from that, it's all coming out okay, and it is indeed detecting things. We have it showing down the bottom there. There you go. Getting some strange readings, but pretty much if I put it down and stop waving it around, you'll see that it is showing 17 centimeters. That's basically how far it is to me. If I put something in closer, it's probably, 10 centimeters, about there. There you go, 8, 7, 6. It is detecting in centimeters and inches the distance something is, which is very, very useful. Obviously, if you're building an intruder alarm, a radar gun, a radio controlled car, this will tell you, obviously, if you're driving towards something, it knows when it's getting closer to something. Very, very useful component and nice to have it working. I don't know how far it goes out. That's basically detecting things up above. 45. There we go. It goes to over a meter, which is basically the roof. There we go. So it works. It looks good. And I'm liking this quite a lot. Let's see what else I can find to show you today. Right, next up we have the joystick module. This is apparently based on the PlayStation 2 joystick controller. It is basically two potentiometers and a switch in one unit. So you'd use it as your thumbstick if you're controlling something. You may find me using one of these very soon on a different project. You'll stick around for looking into that. So this a simple wiring circuit in there. Obviously, I won't go into too much of that, but I will show you the code while I plug this in the pre-arranged sockets where it's going wired up. We're basically printing off, and this is just constantly updating. So just look at the bottom one of the two there. It's showing the X and Y axis going from 0 all the way up to 2023, and the X doing the same in the other direction. And the switch is 1 when it's activated. If you push it in, it turns it off. If I can push it in properly, there we go. So the switch is working X and Y. Well, I'm actually doing it sideways, so that's X and Y the other way around. So it would actually be that way is how it should be mounted. So we're doing the X-axis across that way, and the Y obviously going up and down. Actually, that's backwards, so it's that way around. But the X-axis, I don't know, it's reversed in one way or the other. I can't figure it out. But whichever way, it's programmed and working like that. Useful for controlling things. If you've ever played a game, you've used that to control your character or that sort of thing on a controller. So there we have that. Let's see what's next. Okay, time to dive into the box. Now, this little box comes in the kit. We've already looked at the variable potentiometers. There are other things in here. There's a couple of chips, which I know nothing about. Some simple push buttons, which are lovely. But this corner is the corner that we're looking at today. LEDs. We have... LEDs always used to be red. That's just how they were. We have a red LED, which is set in the code. I'll show you the code briefly. It's going back to the old days when it was nice and easy. All we did, digital right, light high, digital right, light low, with a second of delay in between either of those things. I understand that. I understand how it works. I vaguely remember setting up the pin mode. So light is the output and set it on pin 13. So I understand that. I figured that out. That works for me. I can change the numbers. If we pilot it into a different connection, we could do that. So this is an LED. They come in different colors. If I unplug that from there, it'll obviously turn it off. We can plug this one in the same place there. Forget to say I missed out by a line. We have one in yellow. There are blue. Blue seems to be the way things have gone now. Everyone seems to be using blue LEDs. Not sure why. They look quite cool. They look quite nice and futuristic, but you know. Clear one. What colour is that? White, of course. There we go. White. Yes, that's what we've got in there. White, yellow, red, white, and blue. That is our selection of LEDs in here. There is one other one, which is a special case, which I thought was in there, but isn't. Must be in there somewhere. I'll dig it out, and we'll look at the special case in the next one. There it is. We have an RGB LED, which I shall wire up momentarily and show you that one. It's a little bit different because it's obviously got more legs. So we'll show you that one next time. But for now, LED, simply turning it on and off. They can be used for all sorts of things. They provide illumination to a limited degree. They're more likely to be providing an indication of something working, something happening. There's green as well. I think it's green. I was just going to say, there should be another colour. There is indeed. The one thing to note on these is green is dimmer than the others. It's interesting. It always seems to be the way. Obviously, the white is the brightest, but yeah. One leg is longer than the other. The other is shorter. The long leg is always the positive side, unless you cut it down. But yeah, so you need to make sure you get it right when you wire it up. So that's that. Let me clear these out of the way, build a slightly different circuit, and show you the RGB one next. And here we are with the RGB LED wired up. Now you'll notice there is a single LED and it is showing multiple colours. Not just 3 colours, we've got it going through several different colours from the code provided. And the code provided is indeed here. Basically, it's got 3 LEDs inside there, a R, G and a B, red, green and blue. Using those 3 colours, you can make any colour you like. If you have them all on bright, it makes a white one, as we just saw there. If you just have the red on, it will just be red, obviously. But so here we have a section of code showing us what is on and what is off. The R, G and B values obviously programmed in to be the right pins as it's wired up, as you'd imagine. But we can change things. So as it's got red, green and blue by putting the R, G and B, white by having them all on. Obviously, if you have them all off, it's black, technically. Purple is 170.255, apparently. It's about there. What I shall do is, what can I do? I can copy that. I assume I can copy that. Let's have a look. Copy. There we go. I know you can't see the actual copy bit, but if I go down a line from there, I can paste in that, and we'll change the colour. I don't know what colour it's going to be, so I shall just remove that and just have colour. What should we have? We have something. How about getting rid of the red? If you remove red from RGB, you get green and blue, which should be my colour theory is rubbish. I can't remember what that will be. Let me upload it and we'll find out. So there we have. One that seems to be off. I don't know what that one is. Maybe I stuffed up and made it wrong. I don't know. Maybe the wires are not making proper contact, as they tend to not to on this. Ah, there we go. We have a nice cyan colour. Dodgy blue, white, purple, and then a sort of cyan finish to that. Yeah, you can put in any numbers you like into there. If we were to have 100 to 55 and then 55, I don't know what colour that would be, but let's find out if we upload that. Yeah, after it uploads everything. Slightly brighter, similar sort of colour really, but there we go. So yes, any colour you want, you can make it up. You can find a colour wheel and program it to any colour you like. So on LEDs, all done, sorted, easy. Probably should have started with those because they're quite easy, and even I understand how it works. So yeah, that will do for this look at the sections, the third section. I shall return for probably one more, maybe two more. We'll see. I've got some other things to look at. So stick around. We'll see you probably this time next week. Thanks for watching. See you soon. Bye bye for now.